Right, guys, so we are doing question 7 of the Gauteng 2023 prelim paper. Okay, so it says in the diagram below, PQ and T are 3 points on the same horizontal plane, and MT is a vertical mast. Mast. Okay, MP and MQ are two straight stairwise, and the angle of elevation of M is, of M from Q is theta, and PQ is equal to K, right? So first of all, they tell us that PQ is equal to K, okay? We can see it there, okay? And then furthermore, they tell us that PM is twice that very same PQ. So we can deduce that PM is definitely equals to 2K, right? Cool. So now they give us the area, right? But in this way, the way they give us the area, we can actually rewrite it like this by just swapping the K squared and the 2. And remember that this is an identity, so it's something that we can keep in mind, okay? So let's try and marinate. Right. So now they say that show that MPQ is equal to 2 theta. Right. So MPQ, right, it forms a part of this triangle here. Right. This angle, this triangle that we're looking for, it forms a part of this triangle. This one highlighted in green. Okay. And we've got some information on it actually. So we have a side. Right. Sorry. So we were saying that we've got information on this. We've got two sides, and we're looking for an angle that is between those two sides. Okay. So, and also with this very same triangle, right, we've got the area of it, right, which was given in the question. So now let's try and see something, man. We understand that when we are calculating the area, right, so for us to use the area rule, right, we need to understand something, right? For us to use the area rule, we must have, first of all, an angle, right? So these are the stuff that we should have. We should have the side as well as the side and this included angle. And in this case, we have a similar scenario there. We are looking for this angle, and we have that side and we have this side, right? And they've also given us the area in other terms, okay? So let's try and see something. So the area, right, of triangle MPQ, right, is equals to 1 over 2, one side, which is PQ in this case, multiplied by the other side, which is MP, if I'm not mistaken. Is it MP? Yes, it's MP, okay? Multiplied by MP, multiplied by sine of that included angle, right? So we multiply the side, and this included angle, sine of that included angle, right? So that angle is MPQ, which happens to be the angle that we're looking for. Okay, so now, right, let's see something. Let's just try and what's this and replace it. So it's 1 over 2 into PQ is K, and the other one is what is 2K, okay, multiplied by sine of MPQ. Okay, so now that's what we have there, right? And yeah, let's just simplify this. So half times 2 is going to give us 1. So here we just have K squared multiplied by sine of MPQ. Okay, so we're still looking for this angle MPQ, right? But remember, they've also given us an area here. So let's just rewrite what we've been given there. Okay, so the area of thingy is still the same K squared, right, multiplied by 2 sine theta cos theta, right? So if you notice, what I've done here is that I've just swapped these two, right? Because it's still the same thing. 3 times 4 is the same thing as 4 times 3, right? So I've just swapped them, right? And you will see why it helps, okay? So in this case, what we can do here is, first of all, we can see something here. We can see that this is an identity on its own, right? So let's try and replace that. So now we're going to have K squared multiplied by sine 2 theta, which is a double angle, right? So this is what we have here. And obviously, if you divide both sides by K squared, the K squareds will fall off, right? And also the sines will fall off, okay? All right, so the sine will fall off, right? And yeah, so the rest is history. We can just say 2 theta is therefore equals to MPQ. right? MPQ, okay? And then, yeah, we're done with the first question, right? And yeah, so we're done here. And the next question says 7.2, hence show that MQ is equals to K multiplied by root 1 plus 8 sine squared theta, okay? It's fine. Let's try and check where MQ is. So MQ is this long one, right? So MQ is this long side here, right? So this one, let me just highlight it in a different color, right? So with MQ, it's still part of the very same triangle. And remember, with the triangle, we've got a lot of things now, right? We've got this as 2 theta, right? We've got the other side. We've also got the other side, okay? So the next thing we should also think about is what then can we do to solve that side, right? Considering that we have two sides and an included angle, we cannot, right, by any means use the cos rule, okay? I mean the sine rule, right? Because we don't have two pairs of opposites, right? So we have this angle and its opposite, okay? But we don't have the opposite angle of that side or the opposite angle of the other side, okay? So the only way we can go about this is use the sine rule, okay? I mean the cos rule. But the problem is that when we use the cos rule, we are going to have a problem because they want a sine in the answer. But remember, in this case, we're going to be using the cos rule, right? But the cos rule that we are using, right, is going to be the cos of 2 theta, as you will notice. And the cos of 2 theta has 3 identities, and one of them can be marinated to look like that one. So this is something we should keep in mind, right? So let's try and go ahead, okay? So we know that now, using our cos rule, right, we know that MQ squared, right, is equals to the other two sides that have the included angle, which is what? PM and PQ, right? PQ squared plus PM squared minus 2 into those into the product of those two sides that we've just squared, PQ multiplied by PM, and this is going to be cos, right, of the included angle, right? The included angle of those two sides that we're multiplying together is 2 theta, right? But in this case, we're just, setting it up. So we're just going to say MPQ, okay? Now let's replace. So now we're still looking for MQ. It's still unknown. So MQ squared, we'll keep it like that, is equals to PQ is K. So this is going to be K squared plus, remember that this is what? 2K squared, okay? Minus 2 into K multiplied by 2K cos of 2 theta. Can you see this 2 theta is coming back again? So yeah, we're gonna try and manipulate it to get our answer, right? So the next thing that we should go ahead and do is just to simplify what's on the right hand side, okay? So here we have K squared plus 4K squared. So this is going to give us 5K squared, right? Minus K times 2. Okay, so it's going to be 2 times K times 2K. This is going to be 4K squared multiplied by cos 2 theta, right? So, okay, let's see something, right? So we want to get to this point where we're just going to have the square root, right, of K times the square root of 1 plus 8 sine squared theta, okay? So there's no way in our answer we have a 5 there. So let's try and remove it, or try and manipulate it even further. Let's try and see what we can do. All right. So now we can take out the K squared as a common factor, because these are two terms with a common factor of K squared. Right. Then we're going to have 5 minus 4 cos 2 theta. Right. So we are getting closer and closer to our answer. Right. But the only thing now that's stopping us, right, is because we don't have a 1, first of all, right? And we also have a sine squared theta in our answer. So now we can change that cos into, okay, let's do this. So it's going to be 5 minus 4 into 1 minus sine squared theta. The reason we're changing it into this specific identity is because in what we're trying to prove, we have this guy there, right? So let's try and see if we can manipulate this even further, okay? Let's resume. So this is going to be K squared into 5 minus 4, okay, plus sine, plus 4 sine squared theta, right? So we're moving, okay? So this is going to be k squared. 5 minus 4, this gives us 1, right? Right, so our next step is to change this cos 2 theta into an identity, right? But which specific identity is we're going to change it into the identity that has sine squared theta, because that's what we're trying to prove, okay? So this is going to be equals to k squared into 5 minus 4 into 1 minus 2 sine squared theta, okay? Now we're getting closer to our answer, okay? And yeah, right. So now let's further simplify this. So this is going to be k squared into 5. Now we're multiplying the minus 4 inside. Minus 4, right? Plus 8. 4 times 2 is 8. And negative times a negative is positive. Plus 8 sine squared theta, right? This is the exact same thing as k squared is equals to 1 plus 8 sine squared theta, right? But now remember, this is still mq squared, so this is still mq squared, okay? But remember, we're looking for mq, so mq, right? To get mq, we obviously need to square root both sides, so we're going to square root this and square root that, okay? And yeah, once we square root those, we're going to see that the k squared is going to be affected by the square root directly, so this is going to become k, and then this we can't square root, so we're just going to put it under here, plus 8 sine squared theta, and then yeah, we're done. So we've proven what they wanted us to prove. Okay, so this is how we do this one. And furthermore, they say if k is equals to 139,5 and theta is equals to 42, determine the length of MT, right? So let's see. So they want us to determine the length of MT. Length of MT is this one here, right? But first of all, MT is on a right angle triangle. So we are looking to, to use the Pythagoras theorem or our trig ratios, okay? But in this case, we do not have we do not have 2 sides, right? We don't have the length of 2 sides. So the only way we can go about this one is using the SOHCAHTOA, right? Which is our trig functions, okay? So now we can see that we have theta here. Within this triangle here, we have theta. And we can see that in relation to theta, the side that we're looking for, MT, is opposite. And remember, we've just gotten this one, okay? So we're going to be using sine theta, right? Which is opposite over hypotenuse. So let's just do that. So let's just do this. I'm going to say sine theta, okay, is equals to MT, which is the opposite, over MQ, which is our hypotenuse, right? MQ, not M theta, okay? And then, yeah, so in order to, get MT, right, is the exact same thing as sine theta multiplied by MQ, okay? But remember, our MQ we have, right? We have it in terms of P, of K, I meant to say, okay? So now let's just rewrite it the way we had it. So this is going to be sine theta multiplied by K square root of 1 plus 8 sine squared theta, okay? So this is MT, right? So now they've given us theta, so we just plug theta in there, wherever theta is, and then they've also given us the value of K. You just plug the value of K on your calculator, then you get your answer. And then just remember that they want it to the nearest meter, right? So I believe to the nearest meter, the answer is 200, right? I believe so, okay? And then, yeah, so that's history. And then, yeah.